is that like is that a virtual machine you're entering the commands into, or is that like?
No, this is not a virtual machine. This is the actual. This is an actual Linux environment because I rebooted the computer using the external hard drive, so it's actually rebooting into Linux. I'm running Linux natively.
But it looks like Apple.
Well, Apple Mac OS X is Unix based, so the command line looks about the same as that too.
What distro are you using?
I'm using Debian.
That's kind of started me, just because it sounded like Debian and I thought it
I'm
was
kind of old school. Debian is considered really old school.
A lot of what we're doing is in old school. I said a lot of what we're doing is in old school.
Well, it's
like
old school
Vim.
and not old school, so it depends on what you consider old school.
Vim. Just giving you a hard time.
Okay.
It's kind of funny. The other day I realized I think computer science is the only exact science out there.
Well, computer science is not a science.
Well, I know. That's why it's an exact science.
It is not a science because it does not try to explain, natural phenomena. Instead, it's more of a branch of mathematics where we make up all the rules and then we say, okay, well, based on these rules, what is this computer going to do? Gosh, I forgot to bring my row sheet today.
I have a question.
Yep.
Is computer science considered a STEM field?
Yes, it is.
Oh.
It is the T of the STEM.
I feel important now.
Okay. So computer science is a part of STEM. Does everybody know what is STEM? STEM. Science, technology, engineering, and math. Okay? So computer science actually overlaps between technology, engineering, and also math. So it's part of the intersection of those three particular fields. Technology, we are talking about what we do in silicon. Okay, that's certainly technology. What you can do with computers, with all the gadgets and components. So that's the technology part. Engineering, I think that's not going to be a big question why computer science has to do with engineering. And then math is the fun part. It really is a branch of mathematics. Computer science is a branch of mathematics. It's just kind of more practical, than most math topics. Okay. Alrighty. So let's go ahead and get this class started, and I'll just make sure the screen is setting up correctly. And the first thing we'll do is to go over the homework assignment. Okay. I know this homework assignment is a little bit harder than the other one, but it's still, well, this is the wrong class, by the way. Some of you will be taking this class, the CISP 310, but right now we're going to focus on CISP 360. And what I'll do, I'm just curious right now, so I'm going to go into the homework assignment and just check what is the turn-in rate of this particular homework assignment. Okay, so we are looking at 24. Okay, so out of a class of 32 people, and that's including me as a student, so there are only actually 31 specific students in this class at this point. 24 people turned in, okay, turned in something, okay, which doesn't say anything about the grading part, okay. That's not as many as I would expect, okay, but that's okay. This is still an early homework assignment. And I'm going to change the way I take roll because now everybody has a computer in front of him or her, okay? So the way I take roll now is to give you a passcode. This is the first time I do it, so it may take a little bit of time to set it up. So I go to attendance here, and I go to today's class. I click on this one, and I think I can give it a passcode, so you guys can use the passcode to sign in to basically say that you are here in class. And I think the previous screen may have a code already. Let me just check that. Let's see, it doesn't give me a code here. Edit session, let's see if that would do anything. Attendance keyword is random key, okay. Let me see if I can do this, because if we can do it this way, it will save a lot of time, and I don't have to pass that little piece of paper around at the end or during class. All right. Class setting, report, add session. method is manual. Maybe I have to change method. So let's go back to sessions. Edit this particular one. That's the right one. Okay, so we'll make it semi-auto. And instead of giving it a random key, I'll give you the key, okay? So the key is going to be Vader, V-A-D-E-R. Okay, so let me update first. You won't be able to see anything unless I update it. Alrighty. So now that I have updated it. Oh, okay. The computer generated its own keyword because I forgot to uncheck it. So the keyword to auto sign in to your attendance is lowercase ULQJ lowercase l. Okay, so give it a try. This is the first time I actually tried auto attendance. So it's U lowercase l, Q, J, and then another lowercase l. Okay. Go to the attendance part. Okay, let me sign in as a student myself and see if I can get this done. Okay. So private window. So this way I can sign in as a student without interfering with my teacher account. Okay, so after you sign in as a student, go to the class, and attendance is at the lower left corner of your screen, auto attendance. So you will go ahead and click in detail. And does it give you an interface?
That's not what I got.
Okay, it says not called. Okay, so let me see if we can change that status. Take attendance. Okay. Not called, absent. E is, what E stands for. Okay, we'll make it automatic. Start time, duration. I just turned it into automatic and got rid of random key. So the key is still ULQJL. And let me update it and see what happens. Okay, it is updated on this side. Go back to my student view. Refresh. Okay, so it's automatic now. So I think with automatic, that means if you sign in to Moodle, it will automatically register you as being there. So if I refresh this one here, I should see myself attended already. Okay, so we'll double check. Yep. Cool, that works. All right, that's an easy way to take roll. Okay, so all you have to do is just to sign in, and it will automatically check you in as being in class. Of course, from the IP address, I can also tell where that person is signing in from. So if someone is signing in from home, I can just override it and go like, nope, that does not count as attending. Alrighty, so now that with this done, we can move on to the homework assignment. Alright, so getting to the homework assignment, let me just ask first, what was the main challenge of this homework assignment? Okay. So, Okay, so it sounds like you have the general idea of how to do it. It is formulating, the actual code to make the computer understand what you want it to do. That's the difficulty, right? Okay, so that's one. Go ahead.
I had trouble understanding how to use recursion without being able to add two statements and if else.
But that's the job of a ternary operator. So a ternary operator is one way to do decision making. If something you go on one side, if something otherwise you go on to the other side, right? Okay. Yep.
What really threw me for a loop was the fact that we took one number as the input and we had to give a different number as the output, even though we were still working with the input. And then I remembered the whole
Okay.
first in, last out.
Okay. Last in, first out. Yes. Okay. How many people refer back to the factorial example as a template? 1, 2. Okay. That was the template. Okay, so let's start with the factorial program as a template, and I'll show you guys, how I would approach this problem. Now, of course, it is not fair that I would say, okay, this is how I would approach the problem, because I have got, like 25, 30 years of experience of, programming. But, nonetheless, this is, I will attempt to see it with fresh eyes. Okay. So we'll go ahead and look at the factorial program again, and then we'll try to convert it into. Okay, so the factorial program has one function called f, okay, which is factorial, and one version of the factorial program that I gave you has only one return statement. Okay, so I hope you still remember that. Okay, so in the return statement, the expression is kind of the same thing as what you need to do is to first ask a question and say, is n less than or equal to 0? Okay, in this case, n is less than or equal to 0 is the question to ask. If that is the case, I want the answer to be what? What is the factorial of 0? No, it's 1. Okay, there's one way to arrange nothing. Okay, that's what factorial is for. It is for computing how many ways can you arrange, n items. If you have nothing, then there's only one way to arrange it, because it's nothing, right? Okay, and then the next question is, what if n is greater than 0? Then the number of ways to arrange, n things will be n times the number of ways to arrange n minus 1 things. Okay, and that's the n factorial program. Now, if you really want to make this really clear, which is not necessary in this case, you can also put extra parentheses around the second part. So this way, it is really clear cut. What is the false expression and what is the true expression, or what is the then expression and what is the else expression. Are there any questions about the factorial function itself? Okay, does it ring a bell? I sure hope it does, because this is like the third time we talk about the factorial program that is recursive and make use of a single return statement. Okay? All right, so now we go ahead and write the rest of the code. Int n equals to, let's say, 5, and then n equals the factorial of n, return 0. Okay? So in your program, I use two variables. One to provide the argument to the parameter, and the other one to store the result of the function. In this case, I just use one single variable for both purposes. So in this case, what is the factorial of 5? Just do it by hand first, because otherwise, how do we check the answer? We have to know the answer first. 5 factorial is 5 times 4 times 3 times 2 times 1. And what would that be? It'll be 120, exactly. So 120 should be the answer. So we'll double check that and we'll first compile the program. Okay, now this part is entirely up to you whether you want to turn on warn all or not. In general, it's a good idea to do that, but if you're running short on time or for whatever reason you don't want to turn it on, that's fine. Okay, now we can go into the program. We'll put a breakpoint on line 11, which is where I call the subroutine. So I run the program. Now we are calling the subroutine. If I'm not sure about whether this program is working correctly or not, I will single step into the subroutine and actually see the recursion happen. Because BT or backtrace will help you debug the program to make sure that when you call the same function again, at least the parameter is right. Okay. On the other hand, if I'm pretty sure this program is going to work, I'm not going to use continue, because continue will actually just finish up the entire program, and I did not set up a breakpoint on line 12. I could set up a breakpoint on line 12, but there's a different way to do it. Single step or S will just go into the subroutine, so I have to step over, and I think it's next. Okay, so N stands for next, and what it does is it will skip a function call. Well, not skip, it will perform the function call without stopping in the function that you're calling. So now we are on line 12. We take a look at N is in fact 120. So this program is done. Okay, it is correct. So what I'm going to do next is to change this program into the program that you are supposed to turn in. Okay, because I want to cast the problem that you are supposed to solve into the same format as the factorial program, because otherwise I would not have given you the factorial program as an example. So I'll call this bit counter, or BC, and we'll now take a look at BC. Now obviously the function name is different and the structure of main is a little bit different, but that's not the focus. The focus is what is on line 3. Okay, what do we do on line 3? All right, let's change the name of the function. So it's actually bit counter, BC. All right, so this is bit counter. What is the special case that I can just say, oh, if you give me this value, I can tell you right away the number of bits that are ones in this number? What is the special case? Yep.
0.
0, exactly. So in this case, we can now check whether it is 0 or not. I'm going to make this one the same uin32_t, because when it is unsigned integer, can I have negative values? Nope. So I really do not need to check for negative values, because it's impossible for an unsigned number to be negative. But if you check for negative, it's not going to be a problem. Okay, it will still work. But the next question is, I need to change this, don't I? In other words, if the number that is given to me, okay, if somebody asks me what is the number of bits that are ones in 0, what should be the answer? You told me already a little bit earlier, 0. Okay, very good. So that's the easy part. The difficult part is, oh, but what if that number is non-zero? Then what should I do? Well, I'm lazy. I don't want to count all the bits, okay? The one bit that is very easy for me to count is the least significant bit. Is that okay? The least significant bit is also called bit 0. When we count from right to left, the rightmost digit is also called the least significant bit. Okay? How do I know whether that bit is a 1 or 0?
Mod the original number.
Say again?
Mod the original number.
You can mod with 2. Okay? You can mod n with 2. If you have a remainder of 1, then the least significant bit is a 1. Okay? Or you can do bit shifting. You can do a bitwise AND with just 1. Okay? That will both will serve the same purpose. So let me show you 2 versions of this code. Okay? They will both work. You only have to do one or the other. So with the first version, I'm going to use a bitwise AND operator. So I'm going to say AND, bitwise AND, okay? This is just a bitwise AND because there's only 1 ampersand. If I have 2, it's a logical AND. This is not a logical AND. So I will end it with just 1, okay, as a bit pattern. In the second version, I am going to use AND mod 2. AND ampersand 1, bitwise AND 1, and AND mod 2 will do exactly the same thing. Okay? Why? What is mod 2? Mod 2 is the remainder of a division by 2, right? Okay. What about bitwise AND with 1? What does that do? It ignores all of the other bits and only pay attention to the least significant bit. Okay? But why would it do the same thing as mod 2?
Only return 1 if the least significant digit is 1.
Well, okay, that's right, exactly. Now, if you think about a binary number, okay, and I'll just consider a 4-bit binary number, okay, because that's easier to deal with. The least significant bit, I will just use A to represent it. Next one is B, C, and D. So D, C, B, A are not hexadecimal digits. They are simply placeholders for bit 3, bit 2, bit 2, bit 1, and bit 0. What is the value represented by this thing? It's A times 1, right? Plus B times what? What is the next power of 2? 2 itself, right? Because 1 is 2 to the power of 0. 2 is 2 to the power of 1. C times what? 4. And then D times 8. All right. How can this value be odd? When you look at the value represented by these 4 bits, how can it be odd? Exactly. A is the only bit that can determine whether this number is odd or even. Right? Because the multipliers to B, C, and D, they are all powers of 2 and they are all even numbers. So the only thing that can turn this value into an odd number or determine whether it's odd or even is A. So that means if I ignore all of the other bits and only pay attention to the least significant bit, I can tell whether this number is odd or even. Is that making any sense? And bitwise AND with 1 is going to do the trick, because 1 represented as a binary number will be all zeros on the left-hand side with a single 1 on the right-hand side. And bitwise AND will preserve a bit when you bitwise AND with 1. If you bitwise AND with 0, it will just turn everything into zeros. So bitwise AND with 1 will do the same thing as mod 2, because both will only pay attention to the least significant bit. But this is not the only part of the answer that I need, because this only takes care of the least significant bit, which I'm dealing with. What about the rest of the number? The other 31 bits. I'm going to have somebody else to deal with it. Who is really good at dealing with bit counting in this entire program? BC. Okay? So that's why you have to say, hey, I want to defer that to BC. But now the question is, when you call BC again, how do you specify, quote unquote, the rest of the number? Everything other than the least significant bit. Bit shift, exactly. So you shift all the bits to the right-hand side by 1 position. That becomes, quote unquote, the rest of the bits, right? So you call BC again and say, okay, now we have a, quote unquote, smaller problem for you to solve. When you solve the problem, tell me what the number is. I will add that number to the 1 bit that I am counting, okay, either a 1 or a 0, and I'll return that as my own answer as the number of bits in N, or the number of bit 1s in N. Is that making any sense? Sort of? Okay. So the call, in this case, since I'm using bitwise AND, I would use a bitwise shift. So I'm going to shift N to the right-hand side by 1 position. That's the way we do it this way. Yep, go ahead.
I have a question on N and 1. How would, just for example, you focus on the bit in the second-hand place? So, like after 2 to the 0, 2 to the 1. So in the 2 to the 1 place.
Then the BC, the call to BC is going to take care of it.
No. I mean, can you make N and 1 focuses on the first bit? Can you make N and 2 only focus on the second bit?
Then who's going to take care of the least significant bit?
I don't mean for the homework. I just mean as
an
example.
Yeah,
of
you
a
can.
program.
Yeah, sure.
What would that look like?
Well, you just bitwise AND with 2.
Oh, so the number.
Yeah, if you change, this is just a value that is a power of 2. Now, it doesn't have to be a power of 2. If it's not a power of 2, then you'll have multiple bits that are 1s. So you're not focusing on 1 bit anymore after the bitwise AND.
So if you were to put it to 5, what would N and 5 do when there's
you'll be paying attention to bit 0 and bit 2 only, because 5 is 101 in binary. So those are the only 2 bits you'll be
So it's
considering.
focusing on the zeros, not the ones.
Because anything and 1 is that something, and then anything and 0 is 0. That's based on the truth table of bit of and.
So if it was if it was in binary 111, it would be 1. Yeah, I thought it was either an and statement has to be 1 and 1 equals 1.
It's bitwise, not logical.
But it's bitwise, which means you perform the AND operation on every single bit of the 32-bit number. Okay? All right, but I do want to emphasize this second solution. So the first solution on the first line, on line 5 in this case, is focusing only on bitwise operators. Okay? Bitwise AND is a bitwise operation, and then shifting is also usually considered as a bit operation, bitwise operation. In the second solution, I only use arithmetic operators. N mod 2 is an arithmetic operator, and then n divided by 2 is an arithmetic operator as well. Both will do the same thing. Okay? They're basically identical in terms of what they do in this particular program, so we can choose one or the other solution. They're both considered correct. The parentheses, by the way, are extra. Okay, many of these parentheses do not need to be here. I can basically cross out this pair of parentheses because the priority of the colon is actually lower than the priority of addition, so that does not need to be there. This pair of parentheses does not need to be there because bitwise operation also has precedence over addition. This pair of parentheses I cannot get rid of because this pair of parentheses is enclosing the argument to a function call, and they must be there. So that's the only one that I cannot remove. The comparison, on the other hand here, this pair of parentheses can also be removed because comparison also has a higher priority compared to ternary operator. But in this case, I do want to kind of emphasize, how the operators are grouped and which one is performed first. So I'm going to leave all the parentheses in. Are we doing okay so far with this code? Yes?
The top one you said was bitwise, and the bottom was called what?
Arithmetic. It's just a usual addition, subtraction, multiplication, and division operator. But you can use both. You can use either one to finish this homework assignment. The concept is the important part. Yep.
If those have a higher priority than the ternary operator, does it solve both sides of the operator and then evaluate which one it uses?
Nope. It will always evaluate the first expression, which is n equals 0. That part will always be evaluated first. Based on the result of this, if the expression is true, it will evaluate only this one. If it is false, it will only evaluate the third expression.
Okay, so I guess what's throwing me is then where's the priority of the ternary operator symbol? So it's a higher priority?
It is lower, which means it is, if you do not use parentheses, it's the last thing it will do.
Well, okay, so I guess what's throwing me is the fact that, so the operators in those statements on the other side of the ternary operator have a higher priority than the ternary operator itself, okay?
That is correct.
So why is it that when it evaluates, it just recognizes this
Because,
ternary
okay,
operator then?
okay, so you are thinking of two things. Operator priorities determines how the code is structured. But what gets evaluated at runtime depends on the result of the first expression. Okay, let me show you what I mean by that on the whiteboard. If you are to draw the structure of this entire expression, we'll just take the first one, okay, because the second one is structurally basically the same. So if you look at the first one, the first thing we have is a ternary operator, right?
Yeah.
Okay, it's the last thing that we're going to do, so this is the overall structure. Is that okay?
Yeah.
All right, it has three components. That's why it's called a ternary operator.
I get that.
The first component is, sorry?
Oh yeah.
Yeah, so the first component is, checking whether n equals to 0 or not. Okay? The second component is easy. It's just a constant of 0. The third component, what should I put here? What operator should I put here? It's the last operation of the third part of the ternary operator. What is the operator? No. is the addition, right? It's the summation is the last thing that we do. And summation requires two things, right? So what goes onto the left-hand side? What is the operator on the left-hand side? We're talking about the first line, by the way. The ampersand is the bitwise end. And ampersand requires two things too. One is on the left-hand side. One is n, the other one is a constant of 1, right? The other side of addition is the result of BC. The BC is a subroutine, okay? We're calling the subroutine BC, which requires, in this case, an expression as a parameter, as an argument. So what is in that argument? It has an operator itself. What do you see? How do you name that greater than operators? Bit shifting, okay? So shifting. And bit shifting needs two things, because you need to tell me which bit pattern we are shifting, which is n here, and how many bits are we shifting to the right-hand side, which is 1 position. So when you look at the structure of the code based on the priority, this is the structure of the code. If you remove all the parentheses except for the ones right after BC and the matching close parentheses, it will still give you the same structure based on the priority of the operators. Is that okay? So operator priority will help determine the structure of the code in the absence of extra parentheses. Is that? Yep, go ahead.
But in that diagram, don't you have the ternary operators being a higher priority than?
No, it's the last thing that we do. That's why it has a lower priority. Think about this. A times B, okay, better yet, C plus A times B, okay? The multiplication has a higher priority than the add.
Yeah.
Right?
Yeah.
So what is the last thing that we do? The add.
Yeah.
So if you write the structure of this code here, it is the addition being the last thing that we do, and then the multiplication being the first thing that we do.
So which goes back to what I'm saying is, if it's the lowest priority, then why wouldn't it do all of the other operators before the ternary operator?
Because that's runtime behavior. This is the structure of the code. The runtime behavior says it will evaluate this expression first. Based on the result of that expression, then it will decide whether to evaluate the second or the third expression.
So where's the list that we could find in runtime behavior? So is there a list of runtime behavior priority?
No, because the runtime behavior is not based on the priority. This is the last thing that we're going to do. Oh, I see what you mean. It will always evaluate this first, and then the runtime behavior is just that, okay? It will look at the first expression. Based on the first expression, it will decide whether to evaluate the second or the third expression.
I get that. I guess what I'm trying to say is, like, it would be nice to find a solid absolute list that I could go back to and be like, this is for sure what will happen in this runtime behavior. Like, I guess, although it'd probably be pretty complicated.
That's exactly the description is, if the first expression is non-zero, evaluate and return the second expression. Otherwise, we evaluate and return the third expression. That's the description of the behavior.
Just like what operator precedence in general, not just for ternary.
Yeah. I just mean in general, like for anything, like in case there's, so I would know what differs from operator precedence when in runtime behavior, like where that schism is in the future, in case something else comes up that's similar to this.
Well, that's one, and then the Wikipedia has the other one. Yep.
I'm confused about the multiple invokings of
BC.
the function. Where is your counter to add +1? For example, in the factorial, we had the return statement of the function being times the previous invocation of n. So where in this simple line of code is the +1 addition for when the return statement goes all the way back up, the nesting of the invocations?
Well, when it backs up, it's going to add whatever this returns, right? This becomes a single integer value, and this becomes the other integer value, and then you are computing the sum of those two. So this takes care of the one bit that is the least significant bit of n.
Right.
This takes care of all of the other bits of n.
Right, I understand that, but where where is the return to count how many times it found the 1? Because
It's the return value of BC itself. This entire thing is the return value of BC.
yeah, well, you see what I did in your factorial. You added a multiplication to the return of your function. What I did
but in
was
this case
I added a +1 as an expression. I did this a completely different way. I added a +1. I created a condition where if it was odd, it sent it through a bit shift, and when it went back to return after reaching 0, it would add 1 for every invocation.
Well, I cannot talk about your
Okay,
individual
that's fine.
assignment at this point, but I do want to show you, the structure of the two programs, factorial versus bit counter. Okay, if you look at the structure of the program, they are nearly identical, right? There's a question of whether we should do recursion or not. Okay, if we should not do recursion, what is the answer? Can I answer this question right away without asking again? Okay, if yes, this will answer a 1, this will answer a 0. What about the recursive case? What if we need to do recursion? Then we have the problem broken up into a smaller portion. In this case, it's smaller because now we're trying to figure out the factorial of n minus 1. In the other case, it is smaller because now the least significant bit is taken care of, so we only need to take care of the other 31 bits. But since we're shifting a 0 as the most significant bit, so we know the number is going to get closer and closer to 0. It will never get bigger. It will only get smaller and smaller. Is that okay? And then the only one thing that we have to take care of at this level is the multiplication. What are we multiplying to in factorial? We're multiplying to the n that I am given with. In the other one, it's a little bit more complex because we are adding the return value of BC to whether the least significant bit of n that I'm supposed to deal with is a 0 or 1. So the structure of the code is the same in many ways. It's just that the homework assignment is just one little bit more complex because you have to find whether the least significant bit is a 1 or a 0. Okay. Is that okay so far? Sort of? Okay. Now, if there's any lingering question or lingering uneasiness with recursion, yes?
Can you show in the debugger how when you're adding the invocation to when it compares to 1, can you show how it's giving a number count for the ones in the
Absolutely.
ones
In
place?
fact, I have not tested BC yet, right? And what do you? If there's one thing you learned in my class, what do you learn? You don't take my words for it, right? Okay, so you don't take my words in its face value. So you want me to double check and verify that and validate my programs, okay? And I encourage you to do the same in all of your other classes, even if it upsets your professors. Okay, so let's go ahead and debug, this particular program in GDB. Okay, this is a great example or great way to reintroduce commands that we need to use or techniques to debug programs like this. Okay, so we'll do a GDB BC. Now, obviously, this program is structured a little bit differently from yours because it doesn't have labels. So I'll just put a breakpoint on line 13. Okay, and that will accomplish the same thing as what I need to do with your program. Can anyone guess why I can do this with my own program, and when I'm grading your homework assignment, I have to rely on labels to say where to stop and where to continue? It's because the number of lines can change. Okay, when you write your own code in bit counter, you can introduce like 20 lines of comment to reflect your thought process. So I cannot use a single constant line number to indicate where to set the breakpoint. Now, I can visually go through the program and set a breakpoint, but the whole point is I want a script to be able to do it. So labels is the answer, so I can do it with a script. Okay, so getting back to this one, we'll run the program, And you asked, how do we do the counting? But I will ask an even better question. How do we check this program is working the way it's supposed to? Which test case should I use first to test this program? 0 itself, because that's the case where the recursion should stop, right? If it doesn't work for 0, it doesn't matter what other test cases I have come up with, because none of those is going to work. Is that making any sense? Okay, so we'll check 0 first. So we'll say set var n equals to 0, okay? Then we single step, okay, because I don't really trust myself, so I'm going to single step into the subroutine. Looking at this code, n does equal to 0. How do I know n is 0? Do I need to print n? Just looking at the screen right now, don't look at me, look at the screen. How can I tell what is the value of parameter n? Look up 2 lines from where the blinky cursor is. Well, it's not blinking, but it's green, okay? N is 0, okay? If n is 0, is n 0? I hate to ask that question, but it's what the program is doing, right? The program is asking, you know, n equals to 0 is true, which means what should the return statement be returning? 0, right? Okay. So if I single step, it should go to line 6 with the closed curly brace. And if I single step again, it will go back to main and finish up the assignment operation. So that means at this point, if I print out n, but this time n is a local variable of main, it's 0. I have just proven that the case where there's no recursion is not working. What is the next test case that I should use? I have to give it one test case where it has to go through one step of recursion. What number will force this program to go through exactly one step of recursion? A value of 1. Very good. Okay, so let's check that. So we'll run the program again. Now we stop on line 13 again. Set var n equals to exactly 1. Single step into the subroutine. Okay, this is the first invocation. The first invocation has n equals to 1. So when we ask, does n equal to 0? The answer is no. Okay, so that means we're going to evaluate the third expression of the ternary operator, and I'll highlight which part we are talking about here. So now we're going to evaluate this particular expression. The first part of this expression is n ampersand 1, which is n bitwise and 1. What is 1 bitwise and 1 itself? 1. Okay, so that part is 1. Okay, that's easy. But we have a second part to deal with. The second part to deal with is calling, or the result of calling BC again, but this time the argument is n right shifted by 1 bit. Okay? What is a whole bunch of zeros, a 1, and then right shifting by 1? All zeros. Okay? So we are expecting it to go through the recursion. This is the second invocation. How do we know that this is the second invocation? BT. Okay, BT clearly shows that this is the second invocation. The first invocation is not done yet because it relies on the return value of the second invocation. Then we single step, okay? But before we single step, we want to double check again, okay? N is 0, so in this case, it should return a 0. So we single step, it will go back to the previous one. Now this is the mysterious part because it will go to line 6 again, because when I single step at this point, it will go back to the first invocation, but it doesn't go back to line 5 of the first invocation because it will complete line 5 of the first invocation. It will actually go to line 6 of the first invocation. So that's what we are actually seeing here. And when we single step again, it will go back to main. And what should n be? Should be 1. There's 1 bit that has a value of 1 in the binary representation of the value 1. Let's double check. Print n, it is in fact 1.
How did you get 1 if all you're doing is bit shifting to 0? How is it counting if you're just bit shifting it out?
Because in the first one, this is giving me the 1. This is giving me the 1. When n equals to 1, n bitwise and 1 is 1. That's where the 1 comes from.
Yep, I got it now.
Okay, all right. So here's a question. Okay, I might ask you something like this in the exam. Oh, by the way, I'm going to postpone the exam to next Wednesday because I did not finish all the practice questions on Monday. Hopefully we'll be able to finish more of those today. But this is important, okay? This is really, really important. The question is, how do I make one test case? Okay, there are multiple test cases to fit this criteria, but give me the test cases, there are 2 of them, that will result in 3 levels of function call. This time we have 2, so I wanted to do recursion. It would call recursively twice or to have a total of 3 invocations. If I look at BT, there'll be 3 invocations. Go ahead.
B2.
2 is 1. So if n is 2, that's 1. What is the other one?
Right.
3. Okay? So when n equals to 2 or 3 in main, it will give us 3 levels of function call, or I would say 2 levels of recursion, because the first one is not recursive. Okay. Are there any questions? Yep.
So our code would say X would replace all your n's with X's, right? Because
Right.
it was, okay.
So in your code, it will be the names of the parameters and the variables are different, but the n of as a parameter has nothing to do with the n as a local variable.
And you would, to check it, you're going to be printing bits, right?
Correct. I'll be checking the value in bits. Yep. Are there any other questions? Does anyone want to throw a tricky case to this particular program? Anything that you want to? Yep, go ahead.
It wasn't tricky, it's just the oddity I had with GDB where the file itself will return the correct answer anytime I entered in things manually, even if I did it repeatedly. But when I ran a GDB script, the third case, regardless of what values were put in, would always return the wrong value, even if I would then go in manually, enter the exact same commands in the same order to return the faulty value.
That is odd. Yep. Go
For
ahead.
review, if we're trying to create a break in our program and it says make breakpoint pending on future shared library load, yes or no?
That means you did not use main colon to precede the name of the label. You're setting a breakpoint that is not in that GDB cannot see.
So if I try and put a breakpoint on check here, it's not going to work.
It's main colon check here. Okay, there was another question. Go ahead.
Yeah, I wanted to ask you the syntax of this one. Because for me, I left out from the parents today and it was on the return step, on the return. Yeah, on the return. And then
Yeah.
I put x is equal to 0 and then I left out the open and closing parentheses. So I was a little bit worried in my program because I didn't use the GDB. But later on I picked that up and this is running. So maybe in the near future that I might get lost.
Okay, so what did you put on the return line again?
Yeah, I just left out the open and closing parentheses.
That would be fine because as I said, you can leave out, all of the parentheses are optional in this case. So this program would run exactly the same way without those parentheses. The only pair that needs to be here is this pair. Yeah, all of the other ones are only for clarity purposes, but they do not need to be there. Yeah, but I just usually put in extra parentheses just to emphasize, so I know exactly what is the order of operation. I don't need to memorize the priority of operators. All right. Are there any other questions about this program? No other questions? Okay. Yep.
What happens if you do a number outside of 32-bit parameter?
Then it will be truncated to 32 bits. So it will only look at the least significant 32 bits. Yep.
Is there like, as far as like if you're actually working in the industry, is there a more universal way to do this? Would you say that bitwise is more accepted, or
Well, that's a good question. Okay, so let's take a look at that question. Okay, so the question is, if I look at both versions of this code, okay, so let me give you both versions here. So this is n mod 2 plus bc and divided by 2. Okay, so the question is, in industry, would we prefer line 5 or line 6, right? That's basically the main idea of your question. The answer to that question is, in this particular case, line 5 is preferred because we are counting bits. As a result, we want to use bitwise operations because now we are focusing on not the value represented by the bits, we're only looking at the bit pattern itself. Okay, so in terms of making it clear what we are really doing, line 5 is a better representation of what we are doing. Now, the other thing that you also have to take into consideration is when you use a smaller or slower platform that does not have hardware division, line 6 may actually involve a division operation. Division operation is significantly longer than the bitwise operations of the previous line. So from the efficiency perspective, line 6 is actually really bad compared to line 5. Now, when you're dealing with a Pentium processor, it doesn't make that much of a difference. It's like either way is okay, it's about the same speed. But when you're working with an 16 megahertz, 8-bit processor that cannot do division in hardware, then line 5 is going to be a whole lot faster than compared to line 6. In fact, it will be probably in the order of 50 times, 100 times or so. Line 5 is going to be a whole lot faster compared to line 6. So that's a good question. Yep.
Right now, when line 6 not work, is an odd number?
That is
because it will be 33 divided by 2, for example. Because you're not subtracting 1.
I'm not subtracting 1. Okay, what is 31 divided by 2? What is the quotient of 31 divided by 2?
Quotient.
It's 15. What is 31 right shifted by 1? It's also 15. So they're actually identical. They would do exactly the same thing. Okay, let me ask you another question. What do you think dividing by 2 is going to do in binary representation? It's the same thing as dividing by 10 in base 10. You drop the least significant digit, you shift everything to the right-hand side. So that's why dividing by 2 is exactly the same as shifting to the right-hand side by 1 bit. What about shifting by 2 bits? Shifting to the right-hand side by 2 bit is equivalent to what? Is dividing by what? Dividing by 4. Very good. Shifting by 3 bits. Dividing by 8. Exactly. So they are the same. Yep. Very good. So now, without any additional questions, we are going to move on to the practice questions, or resume in the practice questions. So the practice questions are in, where is it? It's in the previous one, in control structures. There we go. I also added one more piece of note here. It's called parsing nested structures without explicit braces. So you might want to read it because it does bring back the mechanism that we talked about on Monday when we talked about question number 1. So here's question number 2. Question number 2 is asking, what is the effect of the following expression? All right. So what do you think this is going to do? If I give you specific values to begin with, okay? If I tell you ahead of time and say before this expression evaluates, x has a value of 4 and y has a value of 5. Okay, so 4 and 5. So can you tell me what this weird looking expression is going to do to x and y? Is it going to do anything to the variables x and y? And if so, what is it going to do to the values of x and y? That's the question. How do you get started with this one? Yep, go ahead.
Compare y and x bitwise or XOR.
Well, okay, bitwise XOR, okay, exclusive OR. Okay, so the caret is an exclusive OR, but when you combine a caret with an equal symbol, it becomes a compound assignment operation. In other words, okay, where do we start though? I mean, this looks really awfully confusing. So where do we start? How do you evaluate expressions in general using parentheses? You start from the innermost part, right? Okay, so we'll start with y exclusive OR equal to x. What is that going to do? Okay, so let me go ahead and use mousepad to show you what is going on with this one. Okay, so the first thing we will do is basically to say y equals to y exclusive OR x. That's the expanded version of exclusive OR x in the original code. Okay. Now, when you look at y equals to y exclusive OR x, what do you do then? Well, you look at the value of y at this point, you look at the value of x at this point, and then you say, okay, what is the result of the exclusive OR? Does that make any sense? What is y, by the way? What is y at this point? Starting value. Y has a value of 5, and x has a value of 4. What is the result of 5 exclusive OR with 4? 1. The result is 1, okay? It is exactly 1, so that means y becomes 1. Okay, y becomes 1. What about x? Did I change the value of x in doing this assignment? No, x is not on the left-hand side of the assignment operator, so it doesn't get changed. So just to remind ourselves, x kept its current value of 4. It did not change. What about the next thing that we have to do? In other words, at this point, we have resolved this whole thing to a value of 1, but also in the process, y becomes 1. So there are two things that are happening here. Y is changed to 1, but as an expression, this is also given us a value of 1. So what about the next thing? What are we going to do next? We're going to say x exclusive OR equal to 1. Okay, so that's the next thing we're going to do, is to say x equals to x exclusive OR 1. And the x currently has a value of 4. What is 4 exclusive OR 1? 5. Very good. So x becomes 5. So just as a reminder, y has a value of 1 at this point. X now has a value of 5. And what is the last operation that we need to do? It's the stuff outside of the parentheses, right? So that means we are taking, oh, by the way, one more thing. This entire expression also has a value. The value of this entire expression is 5. Okay, it's 5. Okay, so now the last operation is to take this entire thing and say, okay, that's just 5. What is the result of y exclusive OR equal to 5? Let's go ahead and do that. So we'll say y equals to y exclusive OR 5. Y currently has a value of 1. What is 1 exclusive OR 5? We get rid of the 1 because 5 has a 1 as well. 1 exclusive OR 1 is 0. But there's another 1 in 5, and that one we keep. So the whole thing becomes 4. So as the end result, y ends up being 4, x ends up being 5, and when you compare that to the initial condition, what do you think this code just did?
Swap values between the two.
Yep, it exchanged the values of variables x and y, which is a weird way of doing it, because I know most of you learned how to do it using a third variable. But since we have a weird way to use assignment operations in C and C++, we can do it like this too. Yep.
This is similar to the other thing with arithmetic versus division operators. This would be more memory efficient on older systems.
No, it's just tricky. It's actually not much more efficient than the other way. It's just just a tricky way to do it. But this is also a great way to check whether you guys know how to use exclusive OR, and also understand compound assignments would do two things. It will change the variable on the left, but also at the same time, as an expression, it has a value. Yep.
Could you clarify on how the exclusive OR works a little bit?
The exclusive OR has a okay. Exclusive OR is based on the truth table. Okay, once again, is a bitwise operator, which means you look at the bit 0 of the first operand, look at the bit 0 of the other operand. Operand is just one is on the left and one is on the right. You look at bit 0 versus bit 0, and then you perform the exclusive OR, and then whatever the result is becomes the bit 0 of the result. And then you do the same thing with bit 1, bit 2, and so on. Okay? But exclusive OR itself, go ahead, sorry.
So the way you did it quickly is just practicing knowing what numbers are what binary?
Yes. And you are allowed to use calculators. So we can do conversion fairly easily. So bitwise operator is here, and then the exclusive OR is down here somewhere. Bitwise not bitwise exclusive OR. There we go. So that kind of defines the exact behavior of bitwise exclusive OR. Okay. And just another reminder. Okay, this is a repetition. Next Wednesday, when we have our first exam, it is open book, open notes, but it's a paper-based exam. So you guys cannot use the computer, okay? It's paper-based.
We use our phone for calculators?
Hmm?
We use our phone for calculators?
No phones or no electronics that can communicate. If you need a calculator and the only calculator that you have, with you is your phone, I can bring my little bag of calculators and you guys can borrow calculators from me. But if you have a usual TI 8182, something like that, you can certainly use that. Yes, I know those things can communicate too. Yep. Well, I'm trying to go through all of those questions today, so let's see how many of those we can go through today. This is question number 2, so we'll move on to question number 3. Okay, here's question number 3. It is based on a loop, okay? Analyze the following code, show how variable x is updated. For each update, indicate the new value of the variable. You can safely assume variables, there's a typo here. The variables I and x are already declared as integers and with sufficient width to store the values. Use run row to indicate each update of variable x. So I want you to show me how x is updated throughout the code from line 1 to line 4. Okay? The answer to this one, this is actually one of the easiest questions of the test of the practice test. So the first one is going to be on line 1. The first update is the initialization. So x gets a value of 0 because of the initialization. The next update is going to be on line 3. Okay? The first time it is updated, what do you think is going to be the value of x on line 3 the first time?
0?
No. Okay, so the order of operation with a for loop is this is initialization. This is done before the repetitions happen. This is evaluated for each iteration to determine whether we should stay in loop or whether we should get out of the loop. This is called a post operation. This is only performed at the end of the entire loop. So this is performed after x plus equal to I. So this is happening right after I plus plus is less than 3. I is 0 to begin with. I plus plus will do two things. I plus plus is going to increment the value of I, so I becomes 1. However, it will come the value of I plus plus is the value of I before the increment. So it will just return a value of 0 to compare against 3, even though it does increase the value of I so that it becomes 1. Is that clear? Because that's the most confusing part of post increment, because it is called post increment because the expression will be the value of the variable before the increment. But the variable does increase by 1 as a side effect of the operator. Yep.
And increases by 1 right when the program goes back to reading line 1, right?
Yes, but we're not quite there yet. So now we are on line 3. I has a value of 1 at this point. X plus equal to 1 increases x by 1. X started off with a value of 0. So the first time we get to line 3, we will end up adding 1 to x, so x becomes 1. Yes?
I thought you said it was a post, so wouldn't x still be 0 before it actually goes back to 1?
No, because x plus equal to 1 happens right there, but happens right on line 3.
So what is the how did I plus plus come into it? If
I plus so plus plus I happens right after line 3. So right after line 3, we do a plus plus I. I is 1 already at this point, so I becomes 2. And then we go back to evaluate the condition, which is I plus plus is less than 3. I has a value of 2 at this point. Okay? So I++ has a value of 2, even though it does increase I to 3, the expression itself has a value of 2. Is 2 less than 3?
Yeah.
Yes. So it will go to line 3 again, but this time, by the time we get to line 3, I has a value of what? 3. Okay? So now we go back to line 3, and x is incremented by 3, which means it is now 4. After this, we go to the post operation of ++ I. I now goes from 3 to 4, right? And then it goes back to evaluate the part that I have highlighted. I is 4 already, okay? I++ is going to happen regardless because we need to evaluate the left-hand side of the less than to come up with the value to compare against 3. So that means we are actually comparing the value 4 versus 3. 4 is less than 3 is definitely false. But I still gets increased by 1. So if I were to ask you what is the value of I at this point, what is the value of I? What I would have been 5 by the time we get out of the loop. Yep.
Which implementation is happening in the front end? Is that the one being used for the condition statement, so that's just or is it the fact that the for loop has?
Okay. So if you want to look at how these things get evaluated, I can give you a complete order of everything. I get 0 is the very first thing. X get 0 is the second thing. I++ is less than 3. Whoops. Is the third thing. Then because the expression is true, we do an x plus equal to I. Then without questioning, we always do the post operation. Okay, ++ I is the post operation. We always do that without any question. Then we go back and ask this question again, which is still true because at this point, before this expression, I has a value of 2, so we are comparing 2 to 3. 2 is less than 3, but by the time after this expression, I has a value of 3 because of the post increment. So at this point, we'll reevaluate x plus equal to I, and I became 4 at this point. And then we do the post operation without any question. Then we reevaluate the condition. At this point, right before the last time we evaluate I++ is less than 3, I has a value of 4 already. 4 is less than 3 is false, so we get out of the loop. But it doesn't stop the program from incrementing I, so I will still increment from 4 to 5. And after this, we exit the loop, and whatever is following the loop is whatever is following the loop.
Just a question on the syntax of it. Is it doing the incrementation of I because it's the post increment command, or is it because it's in the header in the second
You mean the
position?
++ I?
No, the I++.
The I++ is less than 3 is the condition to determine whether we stay in loop or whether we exit the loop. So it has to be evaluated right before we get out of the loop because this is the question that will give us the answer of whether we stay in loop or we get out of the loop.
But is that incrementation used as the evaluation? Is that actually going to increment I, or is it just going to?
It always increments I after we utilize the value of I for the comparison. That's why it's called a post increment.
Okay, so if it wasn't 0, it would still increment 0 then?
If I was a 0 before, then we'll be comparing 0 to 3. But after the comparison, I becomes 1.
And then that incrementation stacks on to the one being the loop?
Well, since I is 1, then we'll work with I equals 1 afterwards, right? I has a value of 1 after
I
this.
guess a bit of a question. So take the two statements side by side, the I1, post increment, and then if it completes the loop, increment I. So the for loop up there would be after the first semicolon, the next semicolon. Of those two, which is the one that is incrementing it first, and the other one is just incrementing?
The exact order of things happening is like this. That is exactly how it happens. Yep.
For visual clarification, can you put where on that order of operations x is increasing and where the iteration is increasing by 1?
I'm not sure what you're asking.
So on line 4, what would x equal then? Put next to it, what would x equal?
What do you think?
Right there, I think it would be 1.
Yes.
And then what is ++ I doing? So we're adding 1 to I, which would make it 4.
Yes. No. Well, x is 1 at this point. Plus I makes it 2, right? 1 plus 1 is 2.
Plus I. Where was I turned into 1 to begin with? I don't understand how it's going to 2 when it wasn't at 1.
This increases I from 0 to 1.
Oh. Okay. I thought that was just a conditional check, not an actual.
It is also a conditional check.
So it's a check and an increase.
The first thing it does is to take the value of I compared to 3, come up with an answer, but regardless of the answer of that, it will always increase the value of I.
Okay. So, okay, all right. Okay, cool. Now I understand.
Okay, so it indicates to me that we need studying. And we do have a weekend to study. A whole week, in fact. Okay, that was another question, I think. Question? No? Okay. All right. But this one is fun to work with because you can actually type the entire code into a program and run it in GDB. Okay? So I'm not going to do it now because we are running out of time. I got 2 minutes and a half to go over the next 3 questions. I don't think I can actually finish it. But okay, assume you're given several initialized variables as follows. Okay, just a quick reminder, I know we are running out of time, but there is a no food or drink policy in the classroom. Please do not do that. Thank you. Okay, b is the beginning value. This is a non-negative integer guaranteed to be at least 2. E is the end value. It is guaranteed to be larger than b. F is a factor. This is an integer guaranteed to be at least 2. Counter is a counter initialized to 0. You are also given an initialized variable x. Write the code to count the number of integers between e and e inclusively that are divisible by f. Whew. Okay. And the way you count it is you basically make counter the number of numbers between b and e that are factors of f. There's no need to declare any of the mentioned variable. Assume they're all declared. You may also assume the initialization is already done by the initialized variables. Okay, so I want you to write a snippet of code. Okay, a snippet means it is only a section of code. It's not a complete program. Okay, it's just a section of code, assuming certain things are done beforehand already, like the declaration of the variables and the function open curly braces and close curly braces and stuff like that. So we're only focusing on the logic of getting this part done here. How would you do it? Well, to do it in 50 seconds may be a little bit pushing it, but I'll give it a try. No, I do not actually remember the solution. Okay, so what you want to do is to say x equals to x initialized to b, and you want to say that counter is initialized to 0, but it is already initialized, but it doesn't hurt to do it again. And then what you want to do is to basically say if x is less than or equal to e, you want to stay in the loop, okay? And then for each iteration, you're increasing the value of x by 1. So when you look at this code here, this code, the bottom line, okay, so let me just scroll up here. This is basically the structure to say, oh, let me evaluate every single value of x inclusively between b and e. Is that okay? And then the rest of this code, if I do it the long way, this is the long way, there's a short way to do it. But the short way is cryptic, so I'm going to do it the long way. So the long way is basically saying if x mod f, which is the remainder of x divided by f, if that is 0, then x is a multiple of f, and in that case, I want to increase the counter by 1. Or plus plus counter, or counter equals counter plus 1. Pick one of the many ways to increase a counter by 1. That's it. That's the entire program. And I did it in a minute instead of 5 seconds, as I said a little bit earlier.
That's like C+ then.
But that's the idea, okay? That's the nature of the question. Is open-ended. I'm asking you to give me the code to solve a particular problem. But it will only make use of the control structures and the operators that we have talked about. Okay? So I'm not sure whether you guys, will think this is easier or the other questions are easier, but there will be one of each type. Yep.
How many questions?
It will be about 4 or 5 questions. It depends on how difficult the questions are. One thing you guys can do, okay, I know we are running a little bit over time here. I keep all my video recordings. I do not remove the video recordings of the solution of exam 1 from last semester or the one before that. Okay, so if you guys can locate that particular video, you will also know what questions I asked last year and what are the solutions to those questions. And no one and everybody is welcome to hope that I would reuse the questions from last year. Okay, but I do not guarantee that there will be any reuse at all from those questions. But it's not a bad idea, okay, just to assess how many questions and the difficulty level of the questions from last year. I think is a good way to review for your own exam. Alrighty, so I'll see you guys next Monday, and I'll be grading your homework assignment.